Okay, now, still on page 22, the next problem says approximate the zeros of this function. So what I did was I found the axis of symmetry, and then I found f of 4, which was negative 20. So I know my vertex was 4, negative 20. And I noticed this was climbing pretty slowly. 3 was negative 19, 2 was negative 16, 1 was negative 11, 0 is negative 4, and it's not until x hits negative 1 that I see a sign change. So for this one, here's a sign change too. Your answer is going to be approximate. You're going to say x is somewhere in between negative 1 and 0, because I know between negative 1 and 0 there will be a sign change. And x is in between 8 and 9. So if you were asked to solve this by graphing, or if you were asked to solve it by using the chart, you would have to look for a sign change. Now, if I had given you this by graphing, you would have had to continue to pick points, because eventually you'd have to cross the graph. But you don't have to give me an exact value like the book does. You just have to tell me in between two integers. Okay, now, if you turn the page, what we're going to do now is, instead of doing this by the chart method, we're actually going to graph using the coordinate plane. So if you look at page 22A, the first equation is 0 equals negative x squared plus 6x minus 11. Now, if I want to solve the related function, I can write this as a function. So f of x equals negative x squared plus 6x minus 11. I can graph this function, and where it crosses the x-axis would be the solution to this equation. So again, I start out by finding the axis of symmetry, negative b over 2a, so negative 6 over negative 2. So x equals 3 is my axis of symmetry. So here I'll go over to x equals 3. And now I'm going to plug in f of 3. And that would be negative 9 plus 18 minus 11. So f of 3 equals negative 2. So 3, negative 2 is my vertex. Okay, now, my vertex is 3, negative 2, and this is negative. This means I am going to graph this direction. And I don't really have to graph it, because I already know there's going to be no solution, because there's no way I'm going to cross the x-axis. My vertex is already below the x-axis and I'm facing downward. So this is no solution. Okay, now let's look at the next one. Now, the next one I'm going to have you do on your own. There is a solution and they're integers. We are going to do number 3 together, because this has a solution, but they are not integers. So I'm going to show you how I expect you to find the solution when they're not integers. So I'm going to graph my related function, which is negative 2x squared plus 16x minus 28. And I'm going to do that by first finding the axis of symmetry. So I'm going to draw my coordinate plane, my x and y axis. And x equals negative 16 over negative 4. So my axis of symmetry is a positive 4. Put that down there. And then I find the value of f of 4. And when I plug 4 in, I get negative 16 plus 48 minus 28. So that ends up being a positive 4. So 4, 4 is my vertex. Now, it's going to face downward, so I know I'm going to have a solution, right? So I'm going to use the shortcut method. I'm going to go over 1, down 1 squared times a, or down 2. I'm going to go over 2, down 2 squared times a, which is 4 times negative 2, which means I go down 8. Now, notice I'm crossing my x-axis in between two integers. So, my solution is going to be 1, 2, 3. Notice I cross x is in between 2 and 3, and the other x is 4, 5, 6, in between 5 and 6. So my solution is x is somewhere in between 2 and 3 and 5 and 6. Okay? Now, you're going to finish this whole page. You're going to graph 1 through 6 to find the solution. My hint to you is number 3 and number 6 are not integral answers. They're going to be between two integers. But 2, 4, and 5 will be exact answers. So stop the video and turn it back on when you're done to check your answers. So stop the video because I'm going to display your answers. So here are your answers. So, okay, number 1 was no solution. Number 2, 2, 4. Number 4, 1, 5. And then number 5 is negative 2, negative 6. And number 6, x is in between 0 and 1, and 3 and 4.